everyone, welcome to my channel. In this video, we study about non-linear differential equation, in particularly equation solvable for x and equation solvable for y. First, let us understand what are all the working rules to find the general solution for a non-linear differential equation of first order but not first degree using solvable for x method. Here, non-linear differential equation of first order but not first degree equation is of the form f of x, y, p which is equal to 0. Here, first step, we have to convert the given problem in the form of x is equal to f of y, p. Here, find the solution with the help of solvable for x means we have to convert the given problem in the form of x is equal to f of y, p. Next step, differentiate the obtained equation with respect to y. Separate the terms containing dp by dy and terms not containing dp by dy. Here, after differentiating the problem that is x is equal to f of y, p, we have to separate the terms containing dp by dy and the terms not containing dp by dy. Next step, in such case, we have to delete the terms not containing dp by dy. That is, we have to delete the terms, that is, you have to neglect the terms not containing dp by dy. Finally, we have to integrate the obtained equation with suitable method of integration. The obtained equation is a solution for a given non-linear differential equation. This is a working procedure to find a non-linear differential equation with the help of method called solvable for x. Similarly, working procedure to find the non-linear differential equation with the help of solvable for y is same as x. That is, first step, here the given non-linear differential equation is of the form f of x, y, p which is equal to 0. Here we have to first convert the given problem in the form of, here solvable for y means we have to take a equation of the form y is equal to f of x, p. Second step, we have to differentiate the obtained equation, that is y is equal to f of x, p with respect to x. Next, separate the terms containing dp by dx and the terms not containing dp by dx. Next step, in such case, we have to delete or omit the terms does not containing dp by dx. Finally, last step, we have to integrate the obtained equation with respect to with suitable method of integration. Finally, we get an equation that is general solution for a given non-linear differential equation with the help of solvable for y method. These two methods are very important method, that is solvable for x and solvable for y. These two methods are very easy method also. We can solve some problems so that you can understand in a better way. Here is the first problem. Solve y minus 2px plus yp square which is equal to 0. So observing the problem here, this is a non-linear differential equation of first order but not first degree, that is p square is nothing but dy by dx whole square. So this is of first order and second degree differential equation. So this is a non-linear differential equation of first order but not first degree differential equation. Take the given data y minus 2px plus yp square which is equal to 0. Here, observing the problem, we can easily say that this is a solvable for x or solvable for y method problem. In the given problem, we have two y terms and only one x term. So this is a non-linear differential equation. We can solve this equation with the help of solvable for x method, because here two y term, only one x term, so we can solve with the help of solvable for x method. Here, first step of solvable for x method is we have to convert the given non-linear differential equation in the form of x is equal to f of y, p. So the 2px which is equal to, here minus 2px, if it goes to the right hand side, that becomes positive sign of 2px which is equal to y plus yp square as it is. Take this p to the right hand side, that goes to the denominator. We get 2x which is equal to, here y plus yp square divided by p, that becomes y by p plus yp square by p. Here pp gets cancelled, remaining is 2x which is equal to y divided by p plus y into p. Here call this as equation number 1. Here this is a first step. Second step, we have to differentiate this equation 1 with respect to y. We get 2 into, here differentiation of x with respect to y is dx by dy which is equal to, here both y and p are function, so we have to apply product rule over here. Here take 1 by p as first function and y as second function. We get 1 by p into differentiation of second function is differentiation of y is 1 plus y into differentiation of 1 by p with respect to y is minus 1 by p square into dp by dy plus, here also y and p both are function, so we have to apply product rule, that is first function into differentiation of p with respect to y is dp by dy plus second function, that is p into differentiation of y is 1. Next step, we know that p is equal to dy by dx. Here we have dx by dy term, so we can take the reciprocal of p as dx by dy, that is the place of dx by dy we can substitute as 1 by p. 2 into 1 by p p which is equal to, here 1 into 1 is 1 by p plus y into minus 1 by p square dp by dy plus y into dp by dy plus p. Here take all the p terms to the left hand side, we get as 2 by p minus 1 by p minus p which is equal to, here we have y into dp by dy, here also y into dp by dy term, so we can take y into dp by dy as common. Remaining is, here we have only 1 plus into minus 1 by p square. Here take LCM as p, we get as 2 minus 1 by p, so we get as 1 by p here, 1 by p minus p like this, that is 1 by p minus p in the left hand side which is equal to 1 minus 1 by p square into y into dp by dy as it is. Here take this term to the right hand side, we get as 1 minus 1 by p square into y into dp by dy minus of this full term, that is minus of 1 by p minus p which is equal to 0. Here this term is 1 minus 1 by p square, here we have 1 by p minus p, so we have to convert this in the form of 1 minus 1 by p square. We can take this as minus p as common, here we get as 1 minus 1 by p square into y into dp by dy minus, if we take this minus p outside the bracket, remaining is, here if we take minus p as common, here no p term, so that you can't take minus p here, so we have to multiply and divide by minus p here, we get as, in the numerator minus p we can take outside the bracket, remaining is 1 by p into p is p square, so we can take this as, here minus sign we have to take this as minus 1 by p square, here if we take minus p common, remaining is plus 1, that is if we multiply minus p inside the bracket, the value is 1 by p minus p itself. Let's see here, if we multiply minus p inside, we get as minus 2 minus plus, here pp gets cancelled, remaining is 1 by p, here same as this, here minus p into plus 1 is minus p, so we have to, if we take minus p outside the bracket, inside the bracket it is minus 1 by p square plus 1 which is equal to 0, so here also 1 minus 1 by p square, here also 1 minus 1 by p square, so we can take common factor as 1 minus 1 by p square, we get as 1 minus 1 by p square into, remaining is y into dp by dy, here if we take all this term as common, remaining is here minus 2 minus plus p which is equal to 0. Next step, here next step of solver for x is, you have to neglect the terms not containing dp by dy, here 1 minus 1 by p square equal to 0 and also y into dp by dy plus p which is equal to 0, but we have to neglect the terms not containing dp by dy, here this is a terms not containing dp by dy, so we can neglect this term, we have to take only this term, that is y into dp by dy plus p which is equal to 0. Next, if we take dy as a LCM, we get as y into dp plus p into dy which is equal to 0. Here next step we have to integrate with using variable separable form, so to apply that method we have to divide by yp, here if we divide throughout by yp means, in first term here y gets cancelled, remaining is dp by p plus, here we have p into dy divided by yp means, here pp gets cancelled, remaining is dy by y which is equal to 0. Here if we divide throughout the equation by yp means, this yp goes to this value also, here also this value also, here y gets cancelled, remaining is dp by p plus, here in this term pp gets cancelled, remaining is dy by y which is equal to 0. Now we can integrate this equation, we get, apply integration, we get as integration of dp by p plus integration of dy by y which is equal to 0. Here we know that integration of 1 by p with respect to p is log p plus integration of 1 by y with respect to y is log y which is equal to some integration constant log c. Here this is of the form log m plus log n, so we can take it as log m into n which is equal to log c, that is if we cancel this log term, or if we take this log to the left hand side, that becomes log into log inverse. We know that log into log inverse value is 1, so we get a value as py which is equal to c, or we can take this as p is equal to c by y. Here this is a method of solver for x. Our aim is to find an equation, that is general solution of an equation which does not contain p value. Call this as equation 2. Here our aim is to find a general solution of an equation which does not contain the term p, that is dy by dx term, so that substitute p value in equation 1, we get, here equation 1 is 2x which is equal to y by p plus y into p, here in the place of p we have to substitute as c by v, that is a general solution for an equation, that is 2x which is equal to y divided by p is c by y plus y into c by y. Here if you take this y to the numerator and here y gets cancelled, the final equation is 2x which is equal to y into y is y square by c plus c. This is a general solution for a given differential equation. This completes the problem. Here, final aim is to find an equation which does not contain p. Here, this is a general solution for a given differential equation which does not contain p. So, this is a general solution for a given non-linear differential equation. Let's solve some more problems so that you can understand in a better way. Here is another problem. Solve x is equal to y plus p square. Here, observing this problem, this is a non-linear differential equation which can be solvable with the help of solvable for x method, or we can solve this equation with the help of solvable for y method, because here only one x term and only one y term. Take the given problem x is equal to y plus p square. Here I am applying the solvable for x method. Here this is an equation of the form x is equal to f of y comma p. So that call this as equation number 1. First step is completed, that is already this is an equation of the form x is equal to f of y comma p. So second step is you have to differentiate this equation with respect to y. We get here differentiation of x with respect to y is dx by dy, which is equal to, here differentiation of y is 1 plus differentiation of p square is 2p into dp by dy. Next step, we know that dx by dy we can write it as 1 by p, which is equal to 1 plus 2p into dp by dy. Take this 1 to the left hand side, that becomes 1 by p minus 1, which is equal to 2p into dp by dy. Next step, take this y to the left hand side and 1 by p minus 1 goes to the right hand side, that becomes 2p divided by 1 by p minus 1 into dp, that is dy, which is equal to 2p divided by 1 by p minus 1 into dp. Here take LCM as p and simplify, we get as dy, which is equal to 2p divided by 1 minus p divided by p into dp. This p goes to the numerator, we get as dy, which is equal to 2p square by 1 minus p into dp. Here this is a equation which contains y in one side and p on other side. Now we can integrating with respect to p and y separately, we get as integration into dy, which is equal to integration of 2p square by 1 minus p into dp. Here in the right hand side we have to integrate 2p square by 1 minus p. If we take 2 outside the integration, remaining is p square by 1 minus p. So to make the simplification easy, we can take in the place of p square as p square minus 1 plus 1. If we cancel plus 1 minus 1, we get a value as p square itself. So in the place of p square, write it as p square minus 1 plus 1. So here we know that p square minus 1, this is of the form a square minus b square, that is a plus p into a minus b. We can write it as a plus p into a minus b. In the place of a we have p and b as 1. So we get as p plus 1 into p minus 1 plus 1. So in the place of p square we can write it as p plus 1 into p minus 1 plus 1. Here we get as, take 2 outside the integration. Here integration of dy is equal to 2 into integration of, in the place of p square we can write it as p plus 1 into p minus 1 plus 1 divided by 1 minus p into dp. Now we can split the value as integration of p plus 1 into p minus 1 by 1 minus p plus integration of 1 by 1 minus p into dp. That is integration of dy, which is equal to 2 into integration of, here we have p plus 1 p minus 1 term. In the denominator we have 1 minus p. So we have to take it as p minus itself. So take minus as common, we get in the denominator as minus of p minus 1 plus, here also integration of 1 divided by, here also we have to take minus common, we get as minus into p minus 1 into dp. Next step, here p minus 1 in the numerator, here also p minus 1 in the denominator, we can cancel. Here also minus sign, here also minus sign, take minus sign outside the integration, we get as integration of dy, which is equal to minus 2 into integration of, here is p plus 1 plus, here we have 1 by p minus 1 into dp. Next step, split the integration, we get as integration of dy, which is equal to minus 2 into integration of p plus 1 into dp plus integration of 1 by p minus 1 into dp. Next we get integration of dy is y, which is equal to minus 2 as it is, into integration of p plus 1 is, here integration of p is p square by 2 plus, here integration of 1 with respect to dp is p plus integration of 1 by p minus 1. This is of the form 1 by x, integration of 1 by x is log x. So in the place of x we have p minus 1, that is log of p minus 1 plus some integration constant c. Call this as equation 2. In the first problem, we can easily obtain the p value so that we can substitute in equation number 1. We get a general solution which does not contain p. But here we get an equation which is so complicated to find the p value. So consider in equation 1, that is equation 1 is x is equal to y plus p square. So x is equal to y plus p square, which implies p is equal to, here x minus y is p square. So we get p value as square root of x minus y. So from the equation number 1, we can substitute p value as root of x minus y. Substitute in the equation 2, p value as root of x minus y, we get as y is equal to minus 2 into p is square root of x minus y whole square. Here p square is square root of x minus y whole square divided by 2 plus p is square root of x minus y plus log of p is square root of x minus y minus 1 plus some integration constant c. So this is a general solution for a given differential equation because here this equation does not contain p. This completes the problem. Here we have another problem. Solve x into p square minus 2yp plus ax which is equal to 0. Take the given data. Observing the problem, here we have to solve this equation with the help of solvable for y method because here we have two x term, only one y term. So we can solve this with the help of solvable for y method. Here first step we have to convert this equation of the form y is equal to f of x comma p. So that take this term to the right hand side, that becomes 2yp which is equal to xp square plus ax as it is. Next step, this p goes to the right hand side, that becomes 2y which is equal to xp square by p plus ax by p. Here pp gets cancelled. Remaining is 2y which is equal to xp plus ax by p. Next step, here call this as equation number 1. Next step is we have to differentiate this equation 1 with respect to x. We get as 2 into, here differentiation of y with respect to x is dy by dx which is equal to, here x and p both are function, we have to apply product rule over here. X into differentiation of p with respect to x is dp by dx plus p into differentiation of x is 1 plus a is constant, take as this into, here x and 1 by p both are function, so we have to apply product rule over here. First function into differentiation of 1 by p is minus 1 by p square into dp by dx plus second function, that is 1 by p into differentiation of x is 1. Next step we have to substitute dy by dx as p. We get as 2p which is equal to, here take this term and this term in one side and remaining p and 1 by p other side. We get as, here we have x into dp by dx plus into minus minus, here you multiply a inside the bracket, we get as ax divided by p square into dp by dx plus p plus into, here a multiply inside the bracket, we get as plus p plus a by p. Here take p plus a by p to the left hand side, we get as 2p minus p minus a by p which is equal to, here in this two term we can take x into dp by dx as common, we get as 1 minus a by p square into x into dp by dx. Here 2p minus p is p, that is p minus a by p as it is, which is equal to 1 minus a by p square into x into dp by dx. Next step, take this value to the right hand side, we get as 1 minus a by p square into x into dp by dx minus of p minus a by p which is equal to 0. Multiply inside the bracket minus sign, we get as 1 minus a by p square into x into dp by dx plus, here minus to minus plus a by p minus p which is equal to 0. Now we can take minus p common, we get as 1 minus a by p square into x into dp by dx plus of minus p into, here we have to take minus p as common, means from the first term you have to multiply and divide by minus p, so that in the numerator we can take common as minus p, remaining is a divided by p into minus p, so that we can take it as minus a by p into p is p square. Here if we take minus p common, means remaining is plus 1 which is equal to 0. Now here also 1 minus a by p square term, here also 1 minus a by p square term, so we can take common factor as 1 minus a by p square. Remaining is, here we have x into dp by dx, here we have plus into minus p which is equal to 0. Here this is a very important step. If we take minus p as common, means here we have only a by p term, so to take minus p common means here we have to multiply and divide by minus p, so that if we cancel the terms we get the value as a by p itself. So if we take minus p common, means remaining is a divided by p into minus p, so that plus into minus we get as minus a by p into p is p square. Here if we take minus p, means remaining is plus 1. This is a very important step rule, remember. Now we can neglect the terms does not containing dp by dx. Here this is a term containing dp by dx, this is the terms not containing dp by dx, so we can neglect this term. We have to take only the terms containing dp by dx, means we get as x into dp by dx minus p which is equal to 0, or if we take x into dp by dx which is equal to, if we take p to the right hand side we get positive sign of p, so take this p to the left hand side and dx and x goes to the right hand side, that becomes 1 by p into dp which is equal to, here if we take dx to the numerator and x goes to the denominator, we get as 1 by x into dx. Now by integration on both the side we get as integration of 1 by p into dp, which is equal to integration of 1 by x into dx. That is integration of 1 by p with respect to p is log p. If we take this term to the left hand side, that becomes minus integration of 1 by x is log x, which is equal to some integration constant log c. This is of the form log m minus log n, so we can take it as log m by n, that is p by x, log of p by x, which is equal to log c, so that we get as p by x value which is equal to c, or we can take p value which is equal to x into c. So substituting this value in equation 1, that is equation 1 is 2y which is equal to xp plus ax by p. So substituting p value as x into c, we get as 2y which is equal to x into, in the place of p substitute as xc, plus ax divided by, in the place of p we can substitute as xc. Here x gets cancelled, here multiply x inside the bracket and simplify, we get as 2y which is equal to x square c plus a by c. Take c as LCM and simplify, we get as 2x which is equal to x square into c is c square plus a by c. This is a general solution for a given non-linear differential equation. This completes the problem. We shall move on to another problem. Solve y is equal to x plus 2 into tan inverse p. Take the given problem. Here, observing the problem, this is a equation of non-linear differential equation which can be solvable with the help of solvable for y method and solvable for x method, because here we have only one y term and only one x term. So here I am applying the solvable for y method. Here this is an equation of the form y is equal to f of x comma p, so that we can call this as equation number 1. Next step, we have to differentiate this equation 1 with respect to x. We get as, here differentiation of y with respect to x is dy by dx, which is equal to, here differentiation of x with respect to x is 1 plus 2 into, the differentiation of tan inverse p is 1 by 1 plus p square into, again we have to differentiate this p with respect to x, that is dp by dx. Next step, we have to substitute dy by dx as p. We get as p is equal to 1 plus 2 divided by 1 plus p square into dp by dx. We take 1 in the left hand side, we get as, here we have, here remaining is 2 by 1 plus p square into dp by dx, which is equal to p minus 1. Here take this dx to the right hand side and p minus 1 goes to the left hand side, we get as dx which is equal to, here 2 divided by, here this p minus 1 goes to the left hand side, becomes, that goes to the denominator, that becomes 2 divided by p minus 1 into 1 plus p square into dp. Next step, by integrating on both the side, we get as integration of dx which is equal to integration of 2 divided by p minus 1 into 1 plus p square into dp. We take 2 outside the bracket, that is integration of dx which is equal to 2 into integration of 1 by p minus 1 into 1 plus p square into dp. Here, to solve this problem, we have to apply various integration method. That is a very important step in solvable for x and solvable for y. Here, integration of 1 by p minus 1 into 1 plus p square into dp, so that here this is a partial fraction method, so we have to use a partial fraction method to integrate this value. Here take this value as equation number 2. By partial fraction method, 1 by p minus 1 into 1 plus p square, take this term and apply partial fraction method for this 1 by p minus 1 into 1 plus p square. Final result of this value we can substitute here, then we can apply integration easily. That is 1 by p minus 1 into 1 plus p square. With the help of partial fraction method, we can write it as a divided by p minus 1 plus bp plus c divided by 1 plus p square. Here, this is a partial fraction in p, so that we can split 1 by p minus 1 into 1 plus p square as a divided by p minus 1 plus, here in the place of bx plus c, here we have to substitute in the place of x as p, so that bp plus c divided by 1 plus p square in the other side. Next step, in the right hand side, cross multiply these two values, we get as 1 by p minus 1 into 1 plus p square, which is equal to, cross multiplying this value, we get as a into 1 plus p square plus bp plus c into p minus 1 divided by, in the denominator we have p minus 1 into 1 plus p square. Here also we have in the denominator p minus 1 into 1 plus p square. Here also in the denominator we have p minus 1 into 1 plus p square, so that we can cancel this term. Remaining is 1 which is equal to, here multiplying all these values, we get as 1 into a is a plus a into p square plus bp into p is bp square minus bp into 1 is bp plus c into p is cp plus into minus c into 1 is c. Here in the next step, here the ap square, here also bp square, so that we can take common factor as p square. Here we have minus bp and here we have plus c into p, so that we can take p as common and write it as, in the left side we can take it as a plus b into p square plus c minus b into p plus remaining is a minus c. In the right hand side we have only one term, so we can take in the form of this. Here we have a plus b into p square plus c minus b into p plus some constant value a minus c. Call this as equation number 4. Here comparing equation 4 on both sides, we get as a plus b which is equal to 0, Similarly, c minus b into p here we have 0 into p, so that we can take c minus b as 0. Here we have 1 which is equal to, here is a minus c is constant, so a minus c which is equal to 1. So comparing this equation we get as a plus b is equal to 0, c minus b is equal to 0, a minus c is equal to 1. Next step, using this equation a plus b is equal to 0, which implies b is equal to, take this a to the right hand side, that becomes minus a. Similarly, c minus b which is equal to 0, substitute b value as minus a over here, we get as c minus of b is minus a which is equal to 0, here minus to minus plus, hence we get c value as, if we take this value to the right hand side, that becomes c value is minus a. Next step, substitute c value as minus a in this equation, we get as, here minus, here also we have minus to minus plus a which is equal to 1. So we get a plus a is 2a which is equal to 1, which implies a is equal to 1 divided by 2. We get a value of a as 1 by 2. Next step, substitute a is equal to 1 by 2 in this equation. We get as, here in the place of a we can substitute as 1 by 2 minus c which is equal to 1. So that take this minus c to the right hand side and 1 goes to the left hand side, that becomes 1 by 2 minus 1. We get a value of c as minus 1 by 2. Here we are doing this procedure because to obtain a value of a, b, c, here obtain a value of a as 1 by 2 and c value as minus 1 by 2. Remaining is we have to find the value of b. For that, take this value, that is a plus b is equal to 0. Substitute a value is equal to 1 by 2, we get as, that is if a plus b is equal to 0 and we know that a value is 1 by 2. Substituting a value as 1 by 2, we get a value of b as minus 1 by 2. Therefore, we get a value of a as 1 by 2, b as minus 1 by 2 and c value as minus 1 by 2. Next step, we have to substitute all the value of a, b, c in equation number 3. We get, here equation number 3 is 1 by p minus 1 into 1 plus p square which is equal to a by p minus 1 plus bp plus c by 1 plus p square. Substitute a, b, c value over here, we get as 1 by p minus 1 into 1 plus p square which is equal to, here a is 1 by 2 by p minus 1 plus b is minus 1 by 2 into p, here c is minus 1 by 2. So we get minus 1 by 2 divided by 1 by p square. Here we can take 1 by 2 as common. We get here 1 by 2 means this 2 goes to the denominator. Here take minus sign as common, that becomes plus into minus minus, and 1 by 2, that means 2 goes to the denominator. We get as 1 by p minus 1 into 1 plus p square which is equal to 1 by 2 into p minus 1. Here plus into minus minus. Here we have here minus 1 by p into p, that is minus p by 2 minus 1 by 2. We can take 2 as LCM. We get as minus p minus 1. So we can take minus common, means the remaining is p plus 1 divided by 2 goes to the denominator, that is 2 into 1 plus p square. Next step, substituting this value in equation number 2. Here the partial fraction of 1 by p minus 1 into 1 plus p square is 1 by 2 into p minus 1 minus p plus 1 divided by 2 into 1 plus p square, so that we can substitute this value in equation 2. That is equation number 2 is integration of dx which is equal to integration of 2 divided by p minus 1 into 1 plus p square into dp. Here take 2 outside the integration. Remaining is in the place of integration of 1 by p minus 1 into 1 plus p square into dp. You can substitute as integration of 1 by 2 into p minus 1 minus p plus 1 divided by 2 into 1 plus p square. Here we can take 1 by 2 as common now. Integration of dx which is equal to 2 divided by 2 into integration of 1 by p minus 1 into dp minus integration of p plus 1 divided by 1 plus p square into dp. Now this equation, that is integration of p plus 1 by 1 plus p square, we can split this as, here 2 gets cancelled. Integration of dx which is equal to integration of 1 by p minus 1 into dp minus integration of p divided by 1 plus p square into dp. Here plus into minus minus integration of 1 by 1 plus p square into dp. Here we know that integration of 1 by 1 plus p square, this is of the form tan inverse p. So to find the integration of p divided by 1 plus p square into dp, here we know that in the denominator we have 1 plus p square. If we differentiate this value, we get as 2p. In the numerator we have only p. So we have to multiply and divide by 2 over here. We get as integration of dx which is equal to integration of 1 by p minus 1 into dp minus, if we multiply and divide by 2, we get as 1 by 2 into integration of 2p by 1 plus p square into dp minus integration of 1 by 1 plus p square into dp. If we cancel this 2 term, the remaining is this equation itself. So we know that integration of 1 by x into dx is log x. So this is of the form 1 by integration of 1 by x dx is log x. So we know that this is integration of 1 by 1 plus x square is tan inverse x. Here in the place of this, here this is of the form integration of f dash of x by f of x into dx. So function in the denominator, the differentiation in the numerator, that is 1 plus p square is f of x. If we differentiate this value, we get a value as 2p, so that we can take it as log of f of x. This is a formula of integration of f dash of x by f of x into dx. So substituting this value of integration, we get as, in the left hand side we have integration of dx is x, which is equal to, here integration of 1 by p minus 1 into dp is log of p minus 1, minus 1 by 2 is constant as it is, into integration of 2p by 1 plus p square into dp is log of, denominator is 1 plus p square, minus integration of 1 by 1 plus p square dp is tan inverse p plus some integration constant c. Next step, this is log of p minus 1 minus here this of the form n log m, so we can take it as log m power n, that is log of 1 plus p square whole power 1 by 2, we can take it as log of root of 1 plus p square, that is x is equal to log of p minus 1 minus log of root of 1 plus p square minus tan inverse p plus c. So this is also of the form log m minus log n, we can take it as log of m by n, that is x is equal to log of p minus 1 by square root of 1 plus p square minus tan inverse p plus c. Finally, if we substitute this value in equation number 1 or we substitute equation 1 in this value, we get a value or an equation which does not contain the value of p, so that is a general solution that or the required solution for a given nonlinear differential equation. We know that equation 1 is given by y is equal to x plus 2 into tan inverse p, so that from the equation 1 we can easily find the value of p, that is tan inverse p, which is equal to, if we take this x to the left hand side we get y minus x, if we take this 2 to the left hand side that becomes divided by 2, that is tan inverse p, which is equal to y minus x divided by 2, or we can take p is equal to, if we take this tan inverse to the right hand side that becomes tan of y minus x by 2, so that substitute p value over here, that is substituting the p value in above equation we get as x is equal to log of, in the place of p as tan of y minus x divided by 2 minus 1 divided by square root of 1 plus p square, that is p is tan of y minus x by 2 whole square minus tan inverse p is tan of y minus x by 2 plus c. So this is a required solution for a given nonlinear differential equation. This completes the problem. So these are all very important question paper problems on solvable for x method and solvable for y method. In next video we study about Claridge's equation. If you have any problems to solve, comment below. Thank you.